So let's take a look at the last exercise of our optimization problem, which is from exercise number 7. There's a piece of wire length 8 centimeter, and then you need to break the wire into 2 pieces to make a circle A and a square B. Okay, so that's a good start. And then you know that the length of the whole wire is actually 8 centimeter, and then we know that the X centimeter part of the wire is used to make this A, and then the balance is used to make this square B. So definitely since we don't have any value for X, it's going to be 8 minus X centimeter. So what does this resemble to us? Since this wire is used to make the circle, it goes to show that this X and this 8 minus X is actually the circumference of those 2D objects. Right? So there's a lot of geometry knowledge that is used in this chapter, but in most cases we will try to give a lot of hint and also the formula that is required to answer the questions for the students in the examinations. So without further ado, we would like to take a look at minimizing the area and then finding what is the X value correspond to it. So your area will consist of a circumference, no, not circumference, but a circle's area of A. It has R, which is a radius, and then the area of a square, which consists of L multiplied with L. So there's a L over here and there's a R. You need to rewrite this R and L in terms of X, because the question will mention that as X varies. That is another way of looking at what is the N variable that we are looking for. So the N variable will be X corresponding to dA dx equals to 0. Somewhere up there. Okay, so let's try to rewrite this R and L in terms of X first. Circumference of a circle is 2 pi R. This one is equal to X. So now you can say that R is equal to X divided by 2 pi. Okay, that's easy. And for the square B, the circumference of a square is just a 4L. L plus L plus L plus L is equal to 8 minus X, and hence our L is 8 minus X divided by 4. Okay, so those are the two things that definitely what we need for this particular question. Alright, so moving on to the second part, the area of A plus B will be pi R square plus L square, which is the area of the square itself. And let's rewrite it using our obtained X terms representing R and L. So you have something like this. So there's a lot of square over here, but still it's pretty much very simple, not as hard as pyramid, at least at the very least. Okay, so we get this one to be X squared divided by 4 pi for the first one, and then for the second one we can simply write it like as long as it's easy to be differentiated. We don't have any question to show asking us to show A is written in whatever terms of X, so it's up to us to rewrite it as long as it's easy for us to differentiate it in this particular step. So this one will be 2 bring up to the front, then it's factorized by 4. You'll have X divided by 2 pi, and then for this part you will have 8 minus X divided by 8. Okay, so you bring the 2 to the front, which is definitely okay. So I think it should be a negative over here because there's a negative X inside. Or if you are not really sure on this part, how to differentiate it in this particular form, it's just a 1 over 16 and then 2 to the front, -1, and then it's become something like this. You can also expand this one because it's pretty simple as compared to other stuff. It will become x squared, and then for the middle part it will become a -16x, and then for the last part it will become a 64, and then all these are separatable with the one value for the denominator. Then this one is differentiated using your sum or difference rule. So let's try to use this one because it's pretty much clearer to a lot of students. Yes, can I just rewrite this one into okay, so now this one you will have x over 8, and then this one, since it's just a -x, then -x become a -1. This is a 4, so when it becomes a 4, if you differentiate it, it will become 0, so it's okay. Now we have this one, and then everything equals to 0. We are trying to find what is our x over here. So firstly, we can use it's better for us to equate the denominator on this end first before we try to put it on the other side. But it's still okay if you try to put 1 on this side and then equate this denominator, and then you can simply just maybe cross multiply later on. Alright, so this part will become x. Yes, I think I will just try to go with the easier method so that students can easily follow. This will become a 1 over 2 pi plus 1 over 8, like this, and equating this denominator, you will get a much more simpler term is 8 pi. So this one is multiplied by 4, this one is multiplied by pi, then you have 8 pi equals to a 1. Then finally your x is equal to this one will multiply going to the top, and this part will go to the bottom side because it's division. Okay, so I think the question mentioned what is the radius. Okay, so what is the radius? We cannot settle down with x only, then we just have to go and calculate our radius with the newly found x. Is a divide by 2 pi, simply say, then you will have 4 over 4 plus pi. So that is the final answer for this question. So hopefully you have fun with this optimization. I know there's a bit of a little bit of hard to understand by just one glance. You need to try this one, and then you need to also try to reread, try to rewatch the videos also at the same time we're trying to answer this section for our application of differentiation. And for the pyramid side, you can try, but we already told you that it is not highly recommended to be asked in the examination because of its tediousness. So all in all, have fun, and see you again in the next video, going out of our extremum problems and into the curve sketching, which is 2.3 subtopic. So stay tuned for the next one.